Okay. So we have two types of resistive forces. One is proportional to the speed, right, in magnitudes, but the resistive force R is always in opposite direction with the velocity. And another case, when the speed is a little bit large, then you have here the R is proportional to V squared. R here in the second case is also in the opposite direction with the velocity, but we have the magnitude of that is proportional to V squared, not to V, as in the second case. So for the first case, you have here slow motion and small object, right? Or all small object. Here, if you have the large objects, then you have to use the V squared instead of V. For example, when you use the parachute, you jump out from the plane, right? And you use the parachute, then the resistive force will proportional to V squared, right? And here you can see some example. The first example is the falling object in water or in the air. Then at the beginning, the resistive force is small because V is small. But under the effects of the gravitational force mg here, the velocity of the object will be bigger, right? You see the vector here will be bigger, then the resistive force will be bigger. Okay, then when you write equation like this, you have mg minus bv. Bv here is r, resistive force, equal to ma. But ma itself is m dv over dt, right? The acceleration is the time derivative of velocity, right? So you have here kind of differential equation, right? You have a equal to g minus b over mv, right? So the here you have the differential equation for v. So you can solve for v, and here is the answer. V will be mg over b multiplied with this term. And if we draw the graph for that, v versus t, you have this curve, right? You see at the beginning, the velocity increase very fast, but then it's the increasing rate will smaller, and then it gets a constant value of Vt, right? After a while. Then we say the Vt here is so-called the terminal speed. The terminal speed you see here, terminal speed, right? And you can find from the equation here that the terminal speed Vt equal to mgb from this equation. So we subtract that here, we put it here, Vt, right? It will take time for that. For example, here, now I don't have the rope anymore. I let the ball here falls down. We have the free fall, right? If I run, it's fall down. Okay. What happened if I have here the air? So I turn on the air resistance here. You can see that with the low speed. Okay. Let's click the run button again. Yeah, it runs. So you can ask, how is the velocity or speed of the object? Then we can measure that velocity, y graph. Then you can see that the graph will be this. You see? Then you can see that for our object here, the terminal speed will be here about 15, right? A little bit more than 15 meter per second. And because in this motion, it's the object falls down, so the velocity is negative, right? Then you can see that it starts from 0, and then the speed will increase, right? And then it reaches the terminal speed of Vt. You see that, right? For how long? You see, 1, 2, 3, 8 seconds, right? So after 8 seconds, our object will get the terminal speed. Yeah. In the real life, we can measure that by letting something fall down from our high building here, central building, right? You have here 12 floor. You can go up and then let something fall down, and with some sensor, we can measure this velocity or speed. Okay? Do you believe me? We can do this kind of experiment some days. Okay, so I think that the rest of the chapter 6, you can read it at home and solve problem, right? Nothing special. Here in the book, you have a experiment with the coffee filter. You know what coffee filter is, right? Normally it's had the cone shape and conical shape, and it will fall down just like I let the ball falls down, and you can measure the terminal speed, right? With one filter, you get this terminal speed. With 2 filter, with 10 filter together, so you increase the mass of the object, then you get this kind of value. And you see that you can have the surfer. Initial speed is 0, and then gravitational force will create the downwards acceleration, right? And after some time interval, he will move with constant speed, right? How big is the speed? You can see that with the skydiver, the terminal speed is 60 meters per second. Is it big or not? 60 meters per second. How many kilometers per hour? Can you answer me? How many kilometers per hour? Can you type in the in the chat box? Yeah, 216 kilometers per hour. Can you drive with this kind of speed? No, don't try that, right? The maximum speed you can have with your bike, your motorbike, is about 140, right? Not 200. And for this kind of speed, you need to have a very safe road, not the highway in Vietnam now. In Vietnam, the maximum speed on the highway is about 120, right? So you cannot use your car, you cannot drive your car with this kind of speed. Okay, so I think that's one all for the 6 the chapter 6 here. I think you can have some times for problem solving. We have some problem here called the chapter 6. For the problem number 1, okay, let's try to solve this. Hãy stop cái recording nha, là phải record lại.